Welcome everyone, thank you for attending. My name is Julien Viard de Galbert and I'm going to present Testing Firmware the DevOps way. I work for ITRenew. For more detail on the company, please watch Alifen's talk. ITRenew is selling OCP hardware under the name Sesame by ITRenew. The firmware we are focusing on today is not any firmware. What we call system firmware is the firmware that starts your computer. You might know it as BIOS or UEFI, but we are interested in the OSF alternative, Linux boot. Yes, we run Linux boot on OCP hardware. Most of the hardware sold under the Sesame by ITRenew brand comes from hyperscale data center decommissioning. During our recertification process, we need to update the firmware. One option is to replace it by Linux boot. The idea behind Linux boot is to place a Linux kernel into the BIOS flash. The Linux userland then implements the bootloader. We use uroot, a Go implementation for that. This was presented to OCP Summit at least since 2018. We do that mainly for maintainability, as Linux boot is open source, but also for security. First, it becomes easier to update components such as microcode. Second, the UEFI footprint is reduced by replacing it with Linux. And as those platforms will run Linux, the kernel is already part of the security audit. It also brings extra features. We got NVMe running on servers that did not support it with their BIOS. Linux boot can also be seen as a framework to integrate the provisioning of your servers into your own infrastructure. But all those features need testing. We want tests to be automated as DevOps do today. We want to keep all the log, the test output, the serial console, and the APMI console. We don't want to run the test again to increase verbosity, but still need a concise view of the test results. The hardware setup was presented last year at OCP Summit by Jean-Marie Verdun. It's basically composed of two servers, one device under test and one to control it. The power supply and flash content for the device under test can be driven by the control server. So let's focus on software now. This is how it looks like. We are displaying the Go test result in a web view. We use Go test because uroot is written in Go, but we extended the test framework with helpers and added another rendering of the output. For those unfamiliar with Go, the test framework will match files ending with _test.go and only compile them for test. It will find all functions starting by test and treat them as test case. Inside functions, one can call t.run to create subtests. The default test output is very concise, a single OK line per package when everything goes well. It's more detailed when there are failures. Or you can ask it to be verbose, but error will be harder to catch in the long log output. Go test also have a JSON output that can be processed programmatically. So, Go test web is an HTML5, CSS and JavaScript application. It parses the output client side, so here is the JSON on the client that's used by this demo. It renders the successful test folded by default and the failures stay open. We'll see that in a later demo. It keeps the test hierarchy. You can see subtests here. And it integrates with a schema. So this is the video of an actual OCP server running Linux boot. You'll see in a moment that it will start the UEFI loader. Then this loader will load the kernel and we'll see uroot booting in a moment. So you see the ASCII logo for uroot here. Then the test is doing a reboot because I had different behavior on cold reboot and warm reboot. The second one is a warm reboot. And you'll see the loader, then the kernel, right now, and it will end on the uroot prompt. So here's the kernel, the uroot, and the prompt. Now if I click on this match Linux boot banner text in the test log, you see that the video has moved to the point where you see starting Linux boot at the top. If I go to starting BZ image here, you see starting BZ image at the bottom, and if I hit play, it's starting the kernel. So it's just the point before booting. If I click on uroot banner, you see the welcome to uroot message on the bottom, and uroot prompt is the actual prompt. But we can do even better than that with a test with two videos. The top one is the serial console, the bottom one is the EPMI console, and I've synchronized them by clicking on this match uroot banner, so you've seen both video ending exactly as you would have seen on the real server. And if I click here on the match uroot banner, you can see the timestamp in those videos is exactly the same. That's because that's how it works. We are matching the timestamp of the log event with the video. So GoTest Web is already available on GitHub. It's developed with web technologies like Bootstrap, jQuery, Reactive.js, and Require.js, but I must say that I'm not a web developer. So let's talk more about the Go part of it. Test7 is the name of the package that handles all that. I choose this name because we have a tool named after wine already, Fiano. This tool is used to modify UEFI flash image to install Linux boot. Test7 provides package to write tests for Linux boot and a go test command that wraps the go test JSON and saves the output needed by go test web. In the test I've shown using another package, go expect. It's an implementation of expect in Go. Expect is a tool used to script behavior on a terminal. It goes like wait for something, send something, wait for something else, send something else, etc. etc. Go expect has spawners, a way to open a terminal to monitor. It provides one for local command, one for SSH sessions, and a generic one that can be extended. So we extended and added 3 more spawners, one to monitor the serial port, one to connect to the EPMI serial over LAN, and the last one to monitor QEMU virtual machines. GoExpect can group sequences of action into a list called a batcher. Each action is represented by an object. We can wait for a regular expression, optionally with a timeout, or send a string. Basically the same operation we've already seen. We extended that as well to provide an action that will match a regular expression and add a log to the test output. The purpose of it is creating those seek points in the video. Now, how is the ASCII-NEMA video created? GoExpect had the feature to send the terminal output to a writer interface. So we implemented this writer interface to write the ASCII-cast v2 file format, so that ASCII-NEMA can replay it. In addition, the open and close log calls are logged so that the GoTest web interface can catch the file name and integrate the video. So you can see this in the blue links in the test output. We also implemented another writer to generate files used by the Unix command line tool script replay. The main bonus of this format is that the text is a plain log and the timing are in a separate file. So we can use the link to simply download the log if you want to open it in your favorite editor. To summarize, we've seen that Test7 provides extension to GoExpect to connect to serial, IPMI, and QEMU. Helper for the batcher interface allowing video synchronization, several log writers. There's also some package to control the hardware from the CI and the basic test suite for Linux boot that match the start sequence. Test20 also provide a command line interface with the gotest command. Gotest run wraps the call to gotest JSON, records the JSON, and still display a plain LOID on the terminal. Gotest serve, on the other hand, will run a local web server to display the result on your browser. That's what I was using for the demo here. And finally, gotest can be integrated into your CI. With the gotest gen command, it will generate all the HTML, JavaScript, and dependencies required to serve the result on a normal web server. I can show you the integration on GitLab. So here is the GitLab project for Test20. And if I go to the job results, and the last one, we can see on the right the job artifact box and the browse button. Click on it, we'll go to the artifacts, public, index.html, and you got the same usual gotest web result, this time served directly by GitLab. So next demo is about the developer live mode with the command gotest live. So I will launch gotest live in the terminal. It's basically doing the same as gotest run, so running the test, and gotest serve, so displaying the test in the web browser, and synchronizing both of them with a WebSocket. So you see the test running currently, and whenever a new line appears on the terminal, it goes on the web view. And there is a failure in that test run, so the failed test remain open on the web view with the red box, while the successful tests have been closed in green. And we can start the video and seek to the failure point, where we can see it received the string different while it was expecting the string same. So that explains the failure here. So questions will be handled by the chat, but don't hesitate to send me an email if you have more questions or any other remark. To conclude, contributions are more than welcome and everything is on GitHub already.